Hello everyone, I hope you're all doing well. My name is Austin Taylor. I am a member of Group 4 along with Michael Nichols, Wade Johnson, and Stephanie Ross. Our presentation today will be on a new campus mapping and navigation system for the University of Michigan. The University of Michigan is a public research university in the state of Michigan. It is one of the top ranked universities in the state with 3 campuses, one in Ann Arbor, which is their main campus, and 2 regional campuses, one in Flint and the other in Dearborn. The University of Michigan has hired our company to implement a new application for students, staff, and visitors that will allow them to locate buildings, rooms, and parking lots with real-time mapping. Additionally, they would like the application to be portable and run on any smartphone platform and tablet or pad device. The application will also include other functionalities such as a rating system to allow the individual to rate departments, instructors, facilities, or classes. The implementation of the application will take place at the Flint campus and will then be implemented in the other campuses. The project is scheduled to be completed by December 23, 2020, and we have been given a budget of $400,000 for the project. Our company was selected to build this application because of our reputation of producing high-quality work for other universities in the state of Michigan. Due to the increased number of students, tightening of schedules, and rescheduling meetings and classes, the current mapping system is no longer an efficient way for students, staff, and visitors to find their way around the campus, and a new system should be created. This will enable everyone to be more efficient in navigating their way around the campus, both inside and outside the buildings, as well as provide people with an easier way to schedule meeting times and locations on the campuses. The purpose of this project is to provide the University of Michigan with a functional, updated solution to their current navigational issues. Currently, students can find maps of the campus if they look on U of M's website, and some of the buildings have maps posted in certain places. This works most of the time, but requires the students to seek out the maps on their own. If students need to get a list of their classes or find their rooms before classes start, they can go on the website and find the page that has the relevant info stored on it. From reaching the home page of the university's website, a student who is very confident with the existing system should be able to find the relevant info in about 2 to 3 minutes. While this is functional, an app solution would greatly improve campus navigation. The information that the student needs can be easily displayed through an app which can be tailored to suit the user's needs. This new system will provide an improved experience for all members of the University of Michigan. Members include prospective students, current students, visitors, and faculty. The application provides users with specific directions and communication, minimizing stress levels and making the user's time with the University of Michigan faster and more efficient. This application will be user-friendly, making the experience for all users quick and easy. Overall, the designed application exhibits a high probability of success. The new application for the University of Michigan will include the following functions and features. Room-level real-time mapping that will lead people to the proper building as well as the correct room and floor level on all campuses. Directions for visitors to appropriate parking lots closest to the building they wish to visit. Information on where and how to access public transportation to and from the 3 campuses. Display the availability of open and full parking spots. Allow individuals to rate faculty, instructors, departments, and classes. Scheduling for social interactions to set up meeting times to meet at a particular location, such as the Bear Bistro. Future-proofing of the application, where we will have an actual plan for including additional features to the application to leave room for growth. And portability that will allow the application to be used on any smartphone platform such as Android, iPhone, BlackBerry, and Windows Mobile Phone, as well as any tablet or pad device.
So when we're looking at the different project roles, first of all, we have the project sponsor. That is simply our client, and all they need to do is make sure they correctly convey the requirements to us, the project managers, as well as the requirements analysts. Again, I myself and the others presenting on this presentation who have so far planned this project are the project managers. The requirements analyst's job is to simply look at the requirements given to us by the sponsor and correctly convey those requirements to other team members so that the requirements are properly met. We will have a project team leader whose job is simply to make sure that the ship is on course and to keep the other team members in line and make sure that the work that needs to get done gets done. We will have a software analyst whose job is to help design the layout of the software and make sure that this software is properly designed and implemented. We will have programmers. Specifically, we will have a lead programmer. The lead programmer's job is to simply, um, if they're the most experienced programmer, and at certain meetings, instead of having all the programmers show up, we would just have the lead programmer. The other programmers, along with the lead programmer, their job is to actually implement the application. Um, we will have a graphical or software designer. Their job is to they will be dealing with anything involving creating interfaces or layouts or any graphical elements to the application. We will have a quality analyst uh, who will seek out problems with the software and report those issues to the proper team member so that they can be fixed as soon as possible. We will have a configuration manager whose job is to make sure that not only that the actual team members working on this project have the proper workspace, but that the actual parts of the project will be properly configured so that when we put it all together, it will work and there will be no issues there. And finally, we'll have an installation specialist who their job is to basically come in at the beginning, uh, make sure that all of the devices we need are properly installed, all the software that we will need is also properly installed on those devices. Basically, just coming in the beginning phases, making sure all the tools are usable, and once they get done with that, they will basically be on standby until we need them again. So when we're looking at stakeholders, the University of Michigan itself is going to be a stakeholder in that they're going to expect not only a functional application, but an application that will also be of a high enough quality to represent the University of Michigan standard. Another stakeholder would be students. Students will be the largest group of users for this application, and they're going to find it very useful not only for finding the building location and getting directions to the building where they had their class, but also getting directions to the classrooms within those buildings, which will be especially helpful when they've never been in a certain building before. Faculty and staff, for a similar reason to students, will also be a stakeholder in the completion of this application. And visitors, again, for a similar reason to students and faculty and staff, will also have some stake in the completion of this application in that visitors will have probably less knowledge on average compared to students, faculty, and staff in terms of the layout of campus, where buildings are, and the layout of the inside of buildings. So they will also find this application very useful.
This slide shows a list of the hardware needed for the project and their associated costs. The two Apple iMac Pros and the three CyberPower PCs will provide our team with excellent speed and storage and will allow our team to be able to develop the application for the University of Michigan quickly. Having multiple computers with different operating systems will additionally allow our team to be able to create a portable application that will work on any mobile phone or tablet or pad device. It will allow our team to split into different groups, allowing some to work on the application to run on iOS operating systems, and others to work on the application to run on Android or Windows operating systems. The Samsung smartphone, iPhone 11, Nokia Luma 930, Samsung tablet, Microsoft Surface Go 2, and the Apple iPad will allow our team to be able to test the functionality of the application as we develop it, to make sure that the application is portable and able to run on any mobile phone or tablet or pad device. This will allow our team to make sure that the interface looks and operates the same across the different operating systems of the mobile phones and tablets and pads. The two HP ProLinux rack servers will allow our team to implement two databases for storing the information for the functions that our application will provide. It will use a Postgres SQL database, which has geographic object and object relational capabilities, and a REAK database, which has graph and social network capabilities and offers high availability of fault tolerance and data resiliency. The 4 Seagate Nitro solid-state drives will provide the databases with ample storage and allow for future growth. The server rack will provide convenient storage for all the networking equipment. The uninterruptible power supply will ensure that in case of a power outage that no damage is inflicted on the system and will help to decrease downtime for the application. The switch, patch panel, and Cat6 cables are to provide our team with a means to connect the equipment that must be physically connected to each other.
As stated in the previous slides, this application is due before December 23, 2020, with an overall budget of $400,000. With this time constraint, it was important for myself and my team to establish a detailed timeline to ensure that we would stay on track for developing our application. As you can see from the timeline below, planning and research phase began in September 2020 and would take around 2 to 3 weeks to complete. We would then move to the application design process beginning October 2020 and lasting about 3 to 4 weeks. For the majority of our project, we worked on the application development portion from November to December 2020, lasting 7 to 8 weeks, which leads to the application release of December 23, 2020. Although the application was released, that does not conclude the end of the timeline because there needs to be a warranty period time in case users find any sort of errors within the application. This will provide an adjustment of services in case of some sort of malfunction, and it will ensure customer satisfaction. And this will be from a time period from December 24th, 2020 through January 31st, 2021. When distributing our budget, the total cost of ownership was essential for our company to calculate. This is because it will help the team identify the direct and indirect costs of our application. The formula used to calculate the TCO is initial cost plus cost of operation plus cost of maintenance plus cost of downtime plus cost of production minus the remaining value. We found the following values to plug in within the formula. The initial cost being $70,000, cost of operation $100,000, cost of maintenance $20,000, cost of downtime $45,000, cost of production $80,000, and the remaining value of $50,000, which got us to $265,000 TCO. Our team strategically left room in the cost it would take us to produce the application provided by Customer X. This is because we wanted to have available funds for future customer requests, errors, and many more unexpected challenges that may occur along the development process.
This is a graphical overview of the app interface, and as you can see, it is broken up into the 3 main functionalities of the app. We have a main screen which shows the 3 categories we put most of our functionality into. Campus navigation under the Campus Navigator option, scheduling under the Schedules option, and student/employee feedback under the Rate My University option. In the campus navigation section, a user can select the campus map option to see a real-time map of the campus. This will show in real time where the user is on the campus, as well as being able to zoom in to see within buildings at room level detail. If a user selects the buildings map option, they will be taken to Figure 3, which is a more detailed building view so that people new to the campus can find information more readily. If a user selects the public transit option, they will be able to look up the bus schedules that are relevant to the campus, as well as access the campus Safe Ride system. Last for the campus navigation is the parking information section. Users will navigate to the parking screen where they can select the type of parking they need, depending on if the user is faculty, student, or a visitor. Once a user selects the correct type of parking, they are presented with the parking lot options available to them. They can follow these options and will be taken to Figure 11, where it will show them how to get to that parking lot on a map, as well as how many spots are available in that parking lot. Next is the scheduling section of the application. The calendar function will automatically display any classes, meetings, or events a user is involved with. The My Classes screen displays info about the classes that a student is enrolled in. The Meetings screen allows students to set up custom meetings at any time and date, and also send invites so that other members of the meeting can add it to their calendar. Last is the Events screen that shows all events that a specific user can sign up for or attend. This screen also allows a student to add that event to their calendar. The last section of the app is the User Feedback section, where users are able to rate aspects of the university that they have had interaction with in order to provide feedback to the university. The screens are broken down into the type of feedback that the user desires to give, be it about a class, an instructor, a department, or a facility at that university. After selecting an item to give feedback on, the user is taken to a screen where they can rate it from terrible to excellent on a 5-point scale, as well as leave extra comments.
So if we want to look at some plans that us project managers have been coming up with and that we'll use throughout the project, first of all, we can look at our estimation plan. So estimations will be done using resource input, which is basically we will look at our resources, both human and non-human resources, and we will estimate how long it will take for them to complete each of their activities. By doing this, we can both estimate a total project time as well as estimate the total cost of the project. Re-estimation will be done with resource input, but we will also be able to use previous work to gauge or better gauge our estimations, as well as we can use outside analyzers, such as perhaps a bank for financial estimation, when we go to re-estimate. Looking at the staffing plan, first of all, because our company is basically us project managers, most other team members will have to be contracted. Uh, these contracted staff will be expected to have excellent knowledge of their position, and they should not require any additional training for the purpose of this project. In terms of keeping track of hours, we have a chart down here, and we can see that for each of the team members. So, for instance, if we look at the requirements analyst in the second row, we can see that they will probably have around 30 hours, we estimate, of work time. We'll only need one of them. They'll be required, especially in the requirements phase of the project, and they should have a rate, an hourly rate of $50 to $75. So this is how we will be keeping track of our staff plan. In terms of our resource acquisition plan, human resources outside the project managers can be contracted. Printing services and computer access can be granted from the University of Michigan, as we will be constructing the application on site. In terms of what software we will need, we can purchase software. If we find free or open source software that fits our needs, that works fine too. There is more details in the infrastructure plan on what software we are using. And finally, for our project repository, Git and GitHub should work fine, as not only do they easily allow for the project to be updated in near real time for the team. But there is also version control as well, which could be useful in the long run. So if we can look here at schedule, resource, and budget allocation. For schedule allocation, we will be using a milestone method. So we can look at how long it takes to complete certain milestones, and we can see if those milestones are being completed on time or not, and then we can adjust accordingly. In terms of resource allocation, this is an example chart in the top right, so we can see that there is a task, create SPMP subplans, and then we can see the resources that will be required to do that. We can see a work time for how long it will take to create the subplans and how it's broken down between the resources. We can see how many days it's expected this will take, and we see start and finish dates. The budget allocation kind of works off that. So we see the SPMP subplans. We can see the same four human resources as well as the amount of time it's going to take them, as we saw above. But now we can compute a total cost for those completing those subplans by the amount of time and the hourly rate of those resources being computed. Project managers can complete risk management using a three-step process on a weekly or bi-weekly basis. The first step is to actually recognize what risks are currently threatening the project. The second step is to actually rate those risks using a risk rating scale from low to high with a medium rating in the middle, as well as give a reasoning for why that risk received the risk rating that it got. We can see this in the chart on the right. The third step is that then the project managers can prioritize uh, higher risks first and continue to observe those higher risks first and give them priority so that they can hopefully be properly managed and brought down to a lower risk rating.
When developing an application, one needs to have the tools, techniques, and software to be able to have a successful project. The following systems are what our team decided to utilize when developing our hardware and software infrastructures. One being the JDK or Java Development Kit for programming the application. The Android SDK tools would make the application compatible with Android devices. Xcode would make the application compatible with iOS devices. The MIT App Inventor for modeling the design of the app interface. Microsoft Office for creating and updating documentation for the project. Kokomo for estimating the cost of the software project. PostGIS SQL database, which has geographic object and object relational capabilities, and the React database, which has graph and social network capabilities and offers high availability, fault tolerance, and it is data resilient. Next, I will discuss the quality assurance plan, which is necessary for any sort of project to make sure that the application being developed has very high quality for the customers and the intended end users. Our quality assurance plan consisted of acceptance testing, which can have a variety of different testing like UAT, BAT, and CAT, and the performance testing, which would show the speed, response time, reliability, scalability, and resource usage of our project. There will be a review and audit chart that will need to be filled out throughout the duration of the project to ensure that the project management standards are being upheld. When finding an error, the team member who finds the error will have to report to the project managers and also provide them with some sort of recommendation on how to improve from these errors. By having a review in place, it will guarantee our project to be successful. And as you can see, the table is something that some of the team members would have to fill out. So the review and audit describes what the review and audit is for. The schedule will show when the review and audit took place, the resources that were required for the review audit, the method, which is a characterization of what was done in the review and audit, and the procedure of how the review and audit is organized and communicated.
To wrap up this presentation, I can quickly talk about these few links in the important references section here at the end of the presentation. The first two are both very similar. One is a link to the Michigan State University campus map, and the other is a link to the University of Michigan Ann Arbor campus map. Both of them provide maps very similar to what our final product would look like, basically without the indoor mapping part. Um, and so these are good examples of what our final product would look like. The third link is actually to a graduate student's thesis, which proposes a product that is similar to ours and presents a good example of a comparable project.
This concludes our presentation. I would like to thank everybody for listening and have a wonderful day.